Welcome back to Control Alt Lead, the podcast from computing where we talk to IT leaders at the sharp edge of strategy and technology leadership. My guest this week is Rolf Krolke, Regional Technology Director at Access Group. Now, Access is a software provider, but we're talking to Rolf as an end user. So, Rolf, thanks so much for joining me today, all the way from Australia.
No, great to be here, Tom. Thanks for having me on the show.
Great. So it's early morning here, late evening for you, but we've made it work.
Here we have.
Okay, so Access Group, really big company. You made up more than 20 acquisitions, I think. So how did you even start turning so many different IT estates into a single coherent platform?
Yeah, and 20 is probably understatement. Access has grown over the last 20 years through multiple acquisitions. So it has been a journey that started before I arrived at Access, and we've obviously carried it on. But we've had the great thing about Access is we've got a multitude of different technologies, and one of the challenges that we have is that we have a multitude of different technologies. So it is an interesting journey around how we manage the estate. I guess the issues that every technology leader has is around how you manage technical debt, how you keep everything updated and secure, but then how do you continue to modernize your platform with all the changes in technology, and then how do you make sure that you are making the right decisions to future-proof some of those decisions that you're making now, because we don't have a crystal ball to know what technology is going to look like in 5 years, and not end up with more technical debt.
Yeah, I remember talking to someone who worked on the big Crossrail project in London, now the Elizabeth line. And when they started it, everyone was on desktops. And by the time they finished it, everyone was working from their smartphones on wireless
Yeah.
underground. So, as you say, you can never predict how technology is going to change over time.
No, it's interesting, and we have the same thing. We have products where customers are still using it on a desktop or a remote desktop, which we offer as a SaaS platform, and now we've got obviously mobile apps as well. So we've got customers consuming it in all different, from all different technology mediums, and we have to manage that and make sure we're delivering them a great, reliable, available, and secure service.
Sure. So you started this big consolidation project in 2022 to bring all of those, disparate IT estates together. What were some of the key choices, and especially architect choices, that you really had to get right to make it a success at the time?
Yeah, so the team went through a process of looking at how do we build out a scalable reference architecture that we could use in, for some of our biggest locations, but also then put in some of our growing locations and be able to essentially scale with how the business wanted to grow. And how does it also accommodate like a multi-cloud scenario? Because we obviously have a large number of data centers around the world where we have our own, hosting platform, but we also, have products in the public cloud. And how do we bring that all together to do a true multi-cloud or hybrid cloud type approach so you can essentially achieve the outcome that you want? So it really started with how does that look? How do we design that out? How does that get built? So the team went and did that. And then they started to look at what are the right vendors to partner with, from the, the network layer, the compute layer, and the multi-tiers of storage that will essentially give us the outcome that we wanted to achieve, but also that they were long-term partners, ones that we could continue to work with and grow with. And essentially, as their technology changed, and this is really important for us, we could just slot that into our architecture. We're not having to change our architecture every time they've brought a new compute platform out or a new storage platform out, or they've changed the types of firewalls, the core switching and backbones and so on. So that became really important, because we run, obviously, because it's all hardware, you're running at least a 5 to 6 year kind of depreciation cycle from a CapEx perspective. But you're also looking at, we have in modular hardware, how can I run that for 10 to 15 years? So we're in the process right now of putting in the upgrading from Cisco UCS to UCSX, and that's potentially gives us a 15-year lifespan, because the chassis are now rated for 15 years, and it's fully modular. And we're doing exactly the same with our storage platforms as we are going through our kind of refresh cycle. We're refreshing with a platform that we can upgrade easily, has a nice small footprint, and we know it is. So we're obviously moving over to pure storage again because it's a modular option. We can swap out the controllers, we can add some additional shelves, we can change the size of the drives, but we can all do that non-disruptively. And for us, that's really, really important because it allows us to scale and grow, but it allows us to maintain our availability, our reliability, and our stability for our customers.
Yeah, modularity is the future. I don't think anyone can
Yeah.
disagree with that. But you mentioned earlier before we started the call, but I'll bring it up again, that Pure wasn't the first vendor you went with. You actually switched to them later. Can you talk about why
We had
that?
we had a multitude of different vendors. So through many acquisitions, we acquire obviously with the acquisition, get their hardware. We had gone down one particular route with another vendor, but we have very diverse workloads, and some of them are very, very resource intensive. And what we found was that pure storage can essentially manage our diverse workloads with little to no engineering work. And for us, that's really important because that allows us to maintain our stability and reliability. But we're not negotiating with the product and engineering teams to add more work to their sprint cycles where they want to be more forward looking. So Pure has allowed us to continue to scale with some of our gnarliest applications or our most heaviest applications that we have, with probably little to no engineering work needed. Now, obviously, we will need to do that as part of the tech debt cycle that every organization needs to do, especially as you need to modernize your platform. But it has given us additional runway for our product and engineering teams to focus on the forward-looking pieces and delivering new features and functionality to customers.
Okay, great. Now, I just want to talk a little bit more about your IT estate because I think we could probably say sprawling is a good word to use. 30,000 virtual
Yeah.
machines, 100,000 databases. What are some of the hardest operational challenges you face with this massive and still pretty diverse estate?
Look, I think one of the things is we do find new equipment, new hardware, and so on that we don't manage. It's still being managed by through whether it's an acquisition or a different part of the business. So then bringing that into the fold. But I think a lot of it has been just around how to maintain a really regular cadence around patching, around managing vulnerabilities, around obviously alerting, how we're staying on top of what's actually happening across the estate. There's obviously lots of noise that comes out of that. So we've obviously got monitoring and everything, but then how do you filter out? So what do we actually need to look at versus what is noise? So we've gone through a whole process of actually standing up an operation, a 24/7 operations team that essentially their core role is to manage that component for us. And they do a great job of doing that. And that has also helped us come leaps and bounds as now we can focus our, platform engineering teams and systems engineering teams on them managing some of the more complex pieces of work, the tech debt that we need to do, and also the future looking stuff as well.
Okay, that actually leads really nicely into my next question, which is at Access Group, you support some really mission critical workloads like NHS payroll, that kind of thing. So how do you design for supporting near zero downtime when you have customers with such high stakes?
So we really need to make sure that we can do proper active um, essentially DR or high availability active probably. So we run if you like, almost a multi-region type setup where we've got, for example, if I take the UK, that runs out a lot of our NHS workloads that we use. That's running out of 2 data centers that are, X number of kilometers apart on different power grids with multiple different circuits coming in, interdependencies. We consider that 2 different regions. Then we also almost build the availability zones inside those with the way that we do everything is cross-connected or quadruply connected. So if one link goes down between, a chassis and a SAN, then we've got 3 more that are sitting there. So it's using that sort of architecture to make sure that the platform layer is up and running. And then we do a lot of work with the engineering teams around helping them to, obviously do testing and helping them think about how to build out for resilience and what does the application need. A lot of it is actually going to understand we can build a highly resilient platform. That's, relatively easy. Anyone that's built that before, it's not too hard. Where it gets complex is then actually understanding how do you get the platform to interact with the application.
Sure.
Because I can fail, and anyone will know if you build it in the public cloud or the private cloud or wherever you put it, you can fail over applications or you can have that, active clustering. But if the applications can't fail over properly, or there is a time period, depending on how the databases work and so on, that's the bit that you've got to think about, understand. And then once you know that, then you can work around, so what does the actual availability look like? How do we actually gracefully fail that over? Do we need to think about like different architectural standards from an infrastructure and application perspective?
Yeah, and we saw the result of not having proper failover capacity just a few months ago with that big AWS outage, didn't we? If
Yeah, and
if things had failed over correctly from US East 1, AWS's big data center, to somewhere else, then that wouldn't have happened.
exactly right. And followed by Azure 2 weeks later when they had their front door issue, which was again very similar lines and then caused almost as much impact to customers.
Yeah, absolutely. So focusing on DR and resilience, I think, is fantastic. Another question about having such a large IT estate. Obviously, you operate in many, many regions around the world. How do you manage local laws, compliance, data sovereignty, that kind of thing, without unnecessarily slowing down the business or the engineering teams?
So what we do is, and again, the architecture that we've built is really cool. So we essentially have two layers. We have a management layer, so we can globally manage, but the actual production layer is completely segregated to the country of operation. So the data doesn't bleed out. It's completely isolated. It's stayed within the borders of the jurisdiction that we're operating in. So if the only people that can actually move data around is if the customer wants to download their data and then put it into another spot. So that's very much the way that we've built that. We've got, we do obviously our ISO certification, which everyone does our SOC certification to verify that is the way that's been architected, and the data can't be moved around unless the customer specifically chooses to do so, which of course they're entitled to because it's their data at the end of the day.
Yeah, so a lot of local control, effectively.
A lot of local control, but centralized management. So that makes it easier for us to manage, but very much local controlled within the jurisdictions that we operate.
All right, great. Makes sense. One final question for you, Rolf, before I let you get off to have dinner or go to bed.
Yeah.
What you've obviously simplified this very complex large IT estate. What would you say is the most important thing that IT leaders tend to get wrong when they go ahead on a project like this?
I think sometimes it is they go panic with the size and the gravity of it all. And I think it's really around, you've just got to take a step back. Yes, they're big the big different estates. They're all architected differently. They were architected by companies at different states of their evolution, by different people with different skills running different platforms. But and I think what the team did was great, is to take a step back, draw on what they had done previously, understand what is the problem that they're trying to solve, and then start off by essentially with a piece of paper or a whiteboard and then drawing out what do we think good is going to look like, and then go and get buy-in from key stakeholders. And the worst thing you can do is just go and get some consultants in to start running at a million miles an hour going, we can consolidate everything, we're going to bring it all together, without actually understanding how does the business work, what is the actual problems that we're going to solve, how the product's going to interact with whatever decisions I make around essentially the IT environment, or the infrastructure environment and the overall platform.
Excellent. All right, Rolf, thank you so much for joining me today on Control Alt Lead.
No, thanks. Always great to be here.
All right. And to our audience, thank you also to you for joining us. We've got plenty more brilliant interviews coming up on Control Alt Lead. But until then, you can always head over to computing.co.uk for more IT research, interviews, and analysis. See you soon.